Hello and welcome back. Let's try t-test and ANOVA now. For t-test, you need to understand few things. One is the IV and the other one is the DV. For the t-test or group comparisons or comparing the means, you always need an IV which is categorical and you need a DV which is based on scale, either on the interval or on the ratio. For t-test and for ANOVA, the homogeneity of variance is assumed, that is the assumption. We'll check how to test the assumption as well. For the t-test can only be done between two categories of the IVs. If you have more than two levels or two categories, then you need to shift towards the ANOVA. As per some references, some books, ANOVA is simply considered as the extension of t-test. So let's do the t-test for now. All you have to do is go for analyze, compare means, independent sample t-test. Independent sample t-test means when the categories are not related to each other, means the participants in one category are not being repeated in the other category. For example, I have is residence. Now the residence is rural or urban. Now the people who are living in urban cannot be categorized as they are also living in rural areas. For the test variables, you can put as many variables as you want. That's not the issue. If you want to use all the variables, you can. All you have to do is just shift the variables. If you have some more variables, you can put them as well. Go for the options and see the confidence interval is already set at 95. So just continue and click OK. These are the group statistics, the mean and standard deviation, the standard error. Standard error is something because the sample is not actually the 100% representation of the population. There is always going to be an error which is defined as standard error. These are the t-tests. Now for the assumption, as I was saying, for Levene's test is used to test the assumption of variances, homogeneity of variances, which is also known as equality of variances or equal variances assumed. These two columns, these two cells are for the Levene's test. T-test starts from here, from this line, where the T is written, from this till the end. So if you look over here on the first row, we'll see SE is social exclusion. The Levene's test is not significant, which means the equal variances that we assume, they are true. So we are going to report the values in the first line, this one and D of this one, significant tail this one. Significance level for the t-test is over here, this one, 0.043. As we know that the value, the significance level, it needs to be maximum 0.05 or below. It cannot be above 0.05. Above means it cannot be 0.050000 even 1. It needs to be exact 0.05 or lower than 0.05. You cannot round off the values for significance level. Again, standard error difference, lower boundaries and upper boundaries, lower intervals and the upper intervals. Once you have the values, you need to identify which differences are significant, which differences are not significant. Let's see, for the AAQ, psychological inflexibility, the Levene's test significance level is 0.026, which means the assumption is not fulfilled over here. The variances are not equally assumed. So for this, what we are going to do is we need to look at the second row, not in the first now, because in case our assumption is not fulfilled, equal variance is not assumed, we need to look at this row. The DF will be changed, significance level will change, although the significance level, the results are not significant, but just to have an idea, if what we do, if this level, significance level for Levene's test is 0.05 or lower. You have to report your values. There are only two tables. One is the descriptives, statistics table, and the other one is the independent sample t-test. Let's look at the APA table now. This is the APA table. You can pause your video and take a screenshot. You can write your table heading over here, italicize the table heading, name of variables, and you need to write the categories of the two IVs, sample size, the DF, the D value, P value needs to be exact. This Cohen's D in the latest versions of SPSS, the Cohen's D is automatically calculated in the output. But where in the earlier version, previous versions, the output does not give you the value of Cohen's D. So what you can do is you can go on your Google. You can just write Cohen's D calculator, and there you have it. You can open it. All you need to do is you need to write the mean, standard deviation, and sample size for group 1, mean, standard deviation, and sample size for group 2, and you will have your Cohen's D. Let's try it from over here. The mean is 37.37. The standard deviation is 15.66. Sample size is 64, and this mean is 44.76. Standard deviation is 18.79. And again, since both the sample size are equal, we can write 64 over here. Calculate, and you have your Cohen's D over here, which is 0.43, and that is written 0.43. Now it's in the minus because the difference was in the minus, T value was in the minus, the difference is in the minus. That only means that your second category, the mean score of the second category is higher as compared to the mean score of the first categories. So you can take a screenshot. They can come in handy over here. And the criteria of static is the same. For 1 star means the p-value is lower than 0.05 but above 0.01. For the 2 star, it's lower than 0.01, and for the 3 star, it's lower than the 0.001. For the symbols that you have used any on this scale or on the variable section, you can write their complete name in the note section. This is your sample size, these are the names, and this is the interpretation or the reporting criteria, reporting style. Whatever the name table has, reveal differences between older adults or whatever your variables are. This you have to focus on, and this is the most important part. You can tell regarding if the scores were higher, as I mentioned over here, that these scores were significantly higher on older adults living separately from children as compared to living with them. Or you can write the values were lower, significantly lower, or significantly different. There are three things that you can write based on the hypothesis that you have, the hypothesis that you generated. You can again take a screenshot over here, and for the Cohen's D, you can write this interpretation. The small effect size has been reported. In the bracket, you can mention the values of Cohen's D. Cohen's D is the effect size. See, that would be done. So now let's move towards the ANOVA. For the ANOVA, again you have to go analyze, compare means, and one-way ANOVA. ANOVA is shorter form for analysis of variance. Let's say we have profession categories as the factor. and you can put as much as Davis as you want. It could be one, it could be two, or it could be multiple. That's completely your choice. Go for the post hoc, click on the OK. If our variance is assumed equally, if the homogeneity of variance is assumed is correct, then we need to apply anything from here. The most common is the 2K test. And if our assumption regarding homogeneity of variance is not correct, then we need to go for either Tamhane or the Games-Orwell. These two are the most popular ones. Press continue. Options, we need descriptives, homogeneity of variance, or we can have the value of Welch as well. Continue. Okay. These are the descriptives: mean, standard deviation, standard error, lower boundaries, upper boundaries, minimum and maximum. These are the homogeneity of variance tests. Now you can see we have 1, 2, 3, and 4, 5, and 6 problematic areas over here. So for these 6, we need to run this test separately, and we need to opt for Games-Orwell. So what we are going to do is, for let's say for Hope and SE or CR, we can go again, analyze, compare means, one-way ANOVA. Just add what you want to, just add the variables that you want only. Let's say I need only 3 is 3. Post hoc, uncheck this one, check this box, continue, and OK. See, now let's go back up a bit. These are the ANOVA values. The F value is considered ANOVA. The significance level is over here. It's telling you if the value, again, the significance level value is 0.05 or lower, it means the results are significant, means there is a significant difference exists between the groups. This table only tells you if any group is different than the other group. It does not tell you the which one. For the group comparison, you need to go for this one, multiple comparison. Now we applied to KHSD first, so let's go to the AAQ, which was significant. This third column is the significance level, and this says this one is significant and this one is significant. So what it means is the job people, they are varying from self-employed people on AAQ. AAQ is psychological inflexibility. Over here, 0.029, self-employed people are again significantly different from the retired ones on psychological inflexibility. This is the ANOVA. If we go down, the analysis that we just ran, these are the descriptives. Again, the ANOVA, nothing is significant, just to show you over here. Now that it's not written as 2K, it's written Games-Orwell, which means we ran a different test over here based on, because our criteria was not fulfilled regarding the homogeneity of variance. So these are again the significance values. Since nothing is significant, there is no point in going down and explaining the results, because no value is below 0.05 or even equal to 0.05. Once you have your results, go to the MS Word and report them as per the APA criteria, APA format. This is the ANOVA one-way analysis of variance, and whatever was significant, just write, maintain the categories: employed, business, housewife, retired. It was job, so write job over here. Business, housewife, retired, these are the F value and these are the DFs. There are two DFs in ANOVA, one is between groups and the other one is within groups, as you can see over here. Between group DF is different and within group DF is also different. So you write two DFs, the F value which comes from here, significance value, for the significance value you need to put the stars. For the post of comparison, if you are required to draw this table, you can draw this table. If it's not a requirement for your exam, for your article, you need to skip this one. But if you want, you can take a screenshot. Let me scroll up first. You can take a screenshot and always remember the sample size as per the AP7, it has gone to the bottom at the notes section. This needs to be corrected. This will go down here. Now this is the interpretation Welch. Now this is the Welch value which was over here. This one, Welch. Put the value from here, statistics and the significance level. Explain the results. If the differences exist among the four groups, tell, and then tell about which one. Just have a look over here. It's specifically telling that older adults having job or employed mean standard deviation experienced more psychological inflexibility than the ones who were doing their business or were self-employed. These results are based on different samples, so the values would be different. You just need to follow your sample, follow the values that you have received in your output. So once you're done, just report your results and write the further interpretation as it is. That's it. That would be all for the ANOVA and for the independent sample t-test. Normal distribution is another assumption which is tested for many of the tests. So for the normal distribution, what you can do is you can go for analyze, you can go to the descriptives, explore, and you can put your DVs over here. You can also put your factors, independent variable over here if you have any. Go to the statistics, see it's again 95% confidence interval is already fixed. That's by default 0.05 level is already there. Go for the plots, check this one normality plots with test, continue, OK, and go for the Kolmogorov Smirnov test. Go down, this says test of normality, so you need to check this one. For the assumptions, the values didn't always need to be at 0.05 above. For the assumption, you do not need the values at 0.05 or below. So as you can see, these values, the significance values on both the tests, they are below 0.05, which means the data is not normally distributed. If your values, significance values on the assumptions, they are significant, it means they are 0.05 or lower. It means your assumption is not fulfilled. You have failed the assumption. So that would be all. I hope that now you understand your t-test and your ANOVA as well.